All right, guys, we finally made it to that final stage in complex number 5, the ATP synthase. So we've been talking about how the energy has been converted from glucose to NADH, FADH, and then the Krebs cycle to FADH2. And those high energy electrons are being transferred to the electron transport chain. And then that energy in the electrons is being transferred into a pressure gradient in the inner membrane space, that pink area. So as the hydrogen ions keep getting pumped up, the pressure gradient is increasing. Imagine a balloon being pumped up. So the more air that you put into that balloon, the more pressurized it becomes. The more pressure that you add to it, the more molecules you add to it, air molecules. And as that pressure increases, the energy increases. So pressure essentially is energy. I mean, what would happen to a canister if you were to immediately stab something into it and pop it? It would immediately pop. It would have a little mini explosion. That is the release of energy. So pressure is energy. So we've converted electron energy into pressure energy. And just like when you inflate a balloon, that air wants to escape. So if you unpinch that nozzle, the air will escape immediately through that narrow nozzle, and it will create propulsion, causing the balloon to kind of flutter away. We've all experienced that. Well, in this case, we have an imbalance. We have a gradient. We have a pressure gradient. And the ATP synthase is that nozzle where that pressure will be able to escape, creating a balance again, because it is imbalanced right now. Now, the ATP synthase is a fascinating molecule because it acts just like a generator, just like a turbine. So as the hydrogen ions flow through the ATP synthase, just like water would through a turbine in a dam, it spins the turbine, and it also spins the generator, and the energy, the pressure energy gets converted. It gets converted into the ADP molecule, converting it into ATP. So the energy is now stored in that third phosphate group. And more hydrogen ions get pumped through. The turbine spins, the generator spins, switching the energy into chemical energy and ATP. And then that ATP will immediately go throughout the body and be used for eyesight, for speaking, for digestion, for respiratory, for cardiovascular, for even thought processes in the brain. So the energy again is converted from pressure system, pressure, hydrogen ion gradient into ATP. And this is where most of the ATP is made, about 30-ish or so per glucose molecule. So again, just to reiterate the point that the ATP synthase works much like a generator. You have water flowing from a dam, from a high pressure system down to a low pressure system. And as that water flows, the turbine spins, and that energy goes into the generator, and the generator converts the water energy, the water movement, into electrical energy. And then the transformer downgrades the energy so that we can use it into our houses and our homes. So the laptop you're using right now to watch this video, the phone, or your lights, or your oven, or your TV that are being powered by electricity right now originate in a power plant where probably you had a dam that was flowing water, turning a turbine into a generator, converting it to electricity. Of course, there's other ways to do this as well, not just water, like with a dam, but we also have wind energy where a wind turbine turns. We also have nuclear energy where that creates steam, pressure, and that pressure turns a turbine, and then that turbine in turn again turns a generator, converting that energy into electrical energy. So this technology, all these really fancy gears that we have in our systems of converting water energy into electricity, these systems, this mechanism already exists in the mitochondria, in the cell already. We just happen to fall upon these principles and develop technology that we use now to make electricity. All right, guys. Well, thanks for watching. I hope